Today, let's go over a medium question in the premium category that I just solved by myself after a lot of trial and error. This one is called number of divisible substrings. So essentially, you're given a integer to string mapping, meaning that letter A is 1, B is 1, C is 2, D is 2, 3, E is 2, F is 3, G is 3, H is 3, and vice versa. And you want to count the number of substrings. So substrings that are where the sum is divisible by the length, and the challenge is to do this without getting time limit exceeded. So the easiest way to do this is using prefix sums and looping through every substring instead of having to loop through every substring of every substring, which is going to result in time limit exceeded because that's O of n cubed, I think, instead of O of n squared. So first of all, let's create our dictionary to map the letters to the values. So we're just going to do this. I for, let's do this. J is for, K is for. I'm sure there's a quicker way to do this, but for the purposes, I'm just going to show you. P6, Q6, R7, S7, T7, U8, V8, W8, X9, Y9, and Z9. So now that we have that, let's create a prefix array to basically sum up the cumulative sums. So, for example, if we were doing ASDF, you would get 1, and then S is 7, so it's going to be 8, and then D is another 3, it's going to be 10. And then F is another, I believe it's 3, so it's going to be 13. Sorry, D is 2. So after you get that, then you can quickly call like every index. For example, if you want to get the sum of this without iterating over everyone, then you do 13 minus, well, if you want to get this one, for SD, the sum would be what? So S is going to be 7, D is going to be 2, so the sum is 9. So you would want to do 10 minus 1, because this index minus the one previous is going to give you the current subarray sum. So 10 minus 1 equals to 9, sum of SD. And you do that for every single one. If the minus 1 is less than or equal to 0, then the whole thing before that is counted. So that's how it works. So let's create our prefix array. So let's call this pre, and for W in Word, let's call this current. Just going to add whatever DW map to. So for A, we're going to go 1. For S, we're just going to add another 7 to it. So current would be 1, 8, 10, and 13 for each iteration. And then we can append current, and let's print pre. Just to show you, okay, now we can actually get all the substrings. J and range I, length of word, and let's call this substring. And now to calculate the length, well, we know the length is always just going to be J minus I, and then the actual sum is going to be, so if I is less than or equal to 0, then the sum is just going to be pre of J, right? So if the sum is like this, we can't subtract anything before that, so it's just going to be whatever this current word is. So ASD would have a sum of 10. If that's not the case, sum would equal to pre-j minus pre-I minus 1, because what we just said is going to be, so for this subarray, it's going to be the current j minus I, which is s minus 1, so 10 minus 1 is 9 for the sum of this subarray. And then we can just ask if the sum divided by the length is equal to 0, then increment the result. And then we can just return the result at the end. If length is so this is +1. And there you go. Because if you divide by 0, for example, only one character has a length of 1, not 0. If you just do, they're both on 0, so I is including starting at j, they're both 0. At the first iteration, the 0 minus 0 is 0. If 1 divided by 0 is not possible. So just a small edge case there, but other than that, pretty straightforward. The good thing is that you can do O of n squared here. You just can't do O of n cubed, so this trick helps. So thank you for watching. I hope you found this helpful, and stay tuned for more content.